automobiles and types of industrial equipment. In this video, we will logically understand the operation and construction of a commercial DC motor. Let's first start with the simplest DC motor possible. It looks like this. The stator provides a constant magnetic field, and the armature, which is the rotating part, is a simple coil. The armature is connected to a DC power source through a pair of commutator rings. When the current flows through the coil, an electromagnetic force is induced on it according to the Lorentz law, so the coil will start to rotate. You will notice that as the coil rotates, the commutator rings connect with the power source of opposite polarity. As a result, on the left side of the coil, the electricity will always flow away, and on the right side, electricity will always flow towards. This ensures that the torque action is also in the same direction throughout the motion, so the coil will continue rotating. But if you observe the torque action on the coil closely, you will notice that when the coil is nearly perpendicular to the magnetic flux, the torque action nears zero. As a result, there will be irregular motion of the rotor if you run such a DC motor. Here is the trick to overcoming this problem. Add one more loop to the rotor, with a separate commutator pair for it. In this arrangement, when the first loop is in the vertical position, the second loop will be connected to the power source. So a motive force is always present in the system. Moreover, the more such loops, the smoother will be the motor rotation. In a practical motor, the armature loops are fitted inside slots of highly permeable steel layers. This will enhance magnetic flux interaction. Spring-loaded commutator brushes help to maintain contact with the power source. A permanent magnet stator pole is used only for very small DC motors. Most often, an electromagnet is used. The field coil of the electromagnet is powered from the same DC source. The field coils can be connected to the rotor windings in two different ways: parallel or series. The result is two different kinds of DC motor constructions: a shunt and a series motor. The series wound motor has good starting torque, but its speed drops drastically with the load. The shunt motor has a low starting torque, but it is able to run almost at a constant speed, irrespective of the load acting on the motor. Unlike the other electrical machines, DC motors exhibit a unique characteristic: the production